Triangular numbers can be modeled by a function suggested in the diagram. If you duplicate each triangular number on top of itself, you can partition the resulting arrangement into an n by n square and a 1 by n row. Graph the function f of n equals 1/2 times n squared plus n and y equals 91 to determine which triangular number 91 is. Use your graph to communicate why any intersection points may be a solution to the equation but not a reasonable solution to the problem. Okay, so notice here that they demonstrate what they mean by rearranging these triangular numbers. So on the top here we have our normal triangular numbers, and then on the second row they show that if you duplicate it, then it ends up being just 1 n by n square. So if n is 1, this first in the sequence, and then 2, 3, and 4, you have an n by n square, or n squared as it shows here. And then you have another row that's just 1 high and then n long. So 3 long when n equals 3. 4 long when n equals 4, etc. And so we want to know what n is when the triangular number is 91. And so it gives us this function for triangular numbers. And so if we just go ahead and graph f of n equals 1/2 n squared plus n, and if we find out where it intersects, y equals 91, then we should be able to find out, well, what n is. Because when f of n basically is 91, or in other words, when they intersect, then we'll be able to see exactly what number in the sequence that would be. So let's go ahead and get out our calculator. And so we can go to y equals menu, and in y1, let's go ahead and put our f of n equation. And I just went ahead and used x instead of n, just because this is a variable that works just fine for us. And then for the second one, we can go ahead and put in y equals 91, and then press graph. And so clearly in our normal window 10 by 10, then it is not nearly big enough to see all the way up to y equals 91. And so you can either go to zoom and then just zoom out. I think I'll just do that actually. Number 3, and press enter. And then it'll zoom out some. It may not be enough still. And so you can see we still can't see our other line. So go again to zoom and then 3, press enter, zoom out. And so now we can see the 2 points of intersection. And you could also just adjust your window. Either way works. And just note here that there are 2 answers for the intersection, but notice that one would be when x is a negative number, or in other words, n is a negative number, and that really doesn't make sense in our sequences. It's going to be positive numbers for n. And so even though that would be a solution to the equations, it's not going to be a solution to our problem. So let's go ahead and find the intersection on the right side by pressing second trace, 5, and then you can just press enter anywhere to the left of that intersection, and then go to the right and press enter again. Press enter one more time, and we see that the intersection is at x equals 13 when y is 91. And so that just means that the number in the sequence will be 13 when the triangular number is 91. So let's go ahead and summarize our answer. The graphs of f of n equals 1/2 times n squared plus n and y equals 91 shows an intersection point at 13, 91. So the 13th triangular number is 91. There's another intersection point where n is negative, but for triangular numbers, we only consider positive integers.